Hello everyone, welcome back to class. This is lecture 2 of introduction of chapter Mensuration, class 8, chapter number 9, Mensuration. Let us see. We were studying about 2D figures. In 2D figures, yesterday we discussed about circle, square and rectangle, about rhombus. Today, few 2D figures left. We will find out their perimeter and area. Let us see. Next figure is parallelogram. Next figure is parallelogram. 2D figure is parallelogram. Let us see what are properties of parallelogram. In parallelogram, opposite sides are equal and parallel. Opposite sides are equal and parallel. Say A, B, C and D. AB side equals to CD and this AD side is equals to this BC. Opposite sides are equal and parallel. Next is diagonals bisect each other, but diagonals are not equal in length. Diagonal bisect each other. Now see, we want to find out its perimeter and area. Perimeter, this length of sum of all these boundaries, that will be its perimeter, and area, the region enclosed by this ABCD parallelogram, that will be its area. Let us see how we can find out its perimeter. Perimeter of parallelogram. Consider this AB side is A, then this BC will be A, and if AD we are considering B, then this BC will be B only. What will be perimeter? Sum of length of all sides of this parallelogram, that is A plus B plus A plus B. 2 times A and 2 times B, that is 2 into A plus B. This will be its perimeter. Let us see how we can find out its area. Area of parallelogram. Area of parallelogram ABCD. Let us draw its height. Perpendicular, you can say, from D vertex to this AB. Say this point is E point. Area of parallelogram will be base into height. Base into height. What is base? Base is AB. If I'm considering this base is AB, then corresponding height will be DE. And if you are considering base this AD, then corresponding to this, you have to draw this one perpendicular. This one. Now we are taking base AB, then its corresponding height will be DE into DE. That is, consider base B and this is H. Then base into height. Area of parallelogram is base into height. Let us see how we can prove this area of parallelogram is base into height. This one was E. Let us see. This is one parallelogram. We have to divide this parallelogram into one rectangle. I will cut this parallelogram along DE. Along DE. I will trim this parallelogram. You can take one paper and draw a parallelogram. You have to draw parallelogram keeping its property in your mind, that opposite sides are equal and parallel. Opposite angles are equal. Draw one parallelogram. After that, draw its height. This DE is height. You have to trim this one height. This portion, this triangle you have to trim. And after trimming, you will arrange this triangle there. This portion, hide this one portion, and then you have to arrange this portion there. Okay, now you will see, if you will focus on this triangle, this one portion, you are getting one rectangle. What you got? One rectangle you got. Rectangle. And this was height h, this will be h only. And what was this side? Let us consider this was a, and then this will be a only. What is area of this rectangle? Area of a rectangle. Area of rectangle will be L into B, length into breadth. So what is length? Length is A and breadth is, this B is H. And if in place of A, you can write base is, this side is B, depend on you, doesn't matter. It is B and this is also B. So it will be B only. So what is area of parallelogram? Base into height, and area of this rectangle is base into height only. This is base into height. So in this way we got area of parallelogram ultimately leads to this rectangle. We can convert this parallelogram after trimming from side this DE, after trim this triangle from this parallelogram and adjust this triangle in this way. Then you will get one parallelogram. Now see, next is next 2D figure is trapezium. Next 2D figure is trapezium. Let us draw trapezium. This is trapezium. Name it A, B, C, D. This is trapezium A, B, C, D. In trapezium, one pair of opposite side is parallel. Just one pair of opposite side is parallel. And now I have to find out its perimeter and area. Perimeter will be simply sum of length of all sides. If these sides are given to us, then easily we can find out its perimeter. How we will find out its area? Area of trapezium. Area of trapezium is 1 by 2 into sum of parallel side, sum of parallel side into height between them. Height between them means height between these two parallel sides. Let us consider this AB side is A and this DC side is B. AB side is A and DC side is B. Draw its height. So this point is E. This is H. It's mean according to this figure, if we will see 1 by 2 into sum of parallel sides. Parallel sides are AB and this DC. This complete is B. Then it will be A plus B into H. 1 by 2 into A plus B into H. Now see how we can prove this area. 1 by 2 into sum of parallel side into and height between them. Let us see how we can prove this one. Okay, let us divide this trapezium into two triangles. One triangle is this and second triangle is this one. Say this point is F point. This point is F point. Now, if it was A, then it will be A only. Say this point, this distance is D and this distance is C distance. Okay, this BF will be H. This trapezium we divided into two triangles and one rectangle. Okay, find out area of these two rectangles and area, one rectangle and two triangles. And we know how we can find out area of triangles and rectangle. Area of triangle ADE plus area of rectangle, this ABFE plus area of triangle BFC will give us area of trapezium. Area of trapezium ABCD. Area of trapezium ABCD will be area of this one triangle, area of this one triangle, and then area of this rectangle. Okay, write down area of triangle ADE 1 by 2 into base. What is base? Base is D into height. Height is H plus what is area of this rectangle? Base into length into breadth. It will be A into H plus area of this one triangle 1 by 2 into base is this FC, that is C, and into height is H. Let us see 1 by 2 D into H, and this combine these two triangle into D into H plus 1 by 2 into C into H plus A into H. Let us see 1 by 2 is common and H is also common from there. Then it is D plus C plus A into H. A into H. Again, if we will see, this H is common in both terms. Take H common. After taking H common, we got 1 by 2 D plus C plus A. H is common, 1 by 2 as it is, this D plus C also as it is, and then this A is also as it is. H is equals to H into 1 by 2 into D plus C plus A. D plus C plus A. Now what will be LCM? It is D plus C plus 2A by 2. Now see, H by 2 as it is, this D plus C plus this A, I can split A plus A, and this D plus C plus A. Let us see in our figure. If I will add D plus C plus A, this D plus A plus C, what I will get? I will get this complete DC. What I will get? Complete DC. H by 2. This DC. DC means that complete side. Now this DC, if you are considering this complete is B. In starting we considered this DC was complete B. Length of this DC is B and this AB side was A only. So in place of DC, what I can write? In place of DC, I will write B and this plus A as it is. So in this way, I got area of trapezium 1 by 2 into sum of parallel side and into distance between them. This is area of trapezium. Let us see again. Area of trapezium is 1 by 2 sum of parallel side into height between them. This is parallelogram ABCD is a parallelogram. I divided this parallelogram into two triangles and one rectangle. This is one triangle and second triangle, and in between it is rectangle. Let us see. We can find out, we know the formula of finding area of triangle, 1 by 2 base into height, and next area of rectangle will be length into breadth, and there 1 by 2 base into height. After writing their base, height, these all dimensions, then what I got? I got 1 by 2 H from this and this one. First I rearranged term 1 by 2 d into h I have written there, and then area of triangle, next triangle I have written, then at last area of rectangle. From these two terms 1 by 2 h is common, d plus c plus a into h. Further, in both terms h is common, 1 by 2 d plus c, and there just a left. Now you have to take LCM. Take LCM or multiply this 1 by 2 with these all. Not multiplying, we are taking LCM. This d plus c as it is, and twice of a, and this 2 will be there. Take this 2 out of this bracket, h by 2, d plus c plus this 2a, I splitted a plus a. If you will say d plus c plus a, what is d plus c plus a? This complete dc side, and dc side is b. dc side is b, and this a as it is. Now I got formula, sum 1 by 2 into sum of parallel side. This a and b are the parallel side of trapezium, and into height between them. So we have discussed all 2D figures, their areas and perimeter, and I told you almost all proofs of these 2D figures of about their areas. Let us see. Now we are going to start our 3D figures. What are 3D figures? In 2D figures, we got two factors of measuring length and breadth. But in 3D figures, there are three factors of measuring their dimensions, like length, breadth, and height. Length, breadth, and height. That figures are 3 dimensions figure. And examples of 3 dimensions figures are cube, cuboid, cylinder, cone, pyramid. In which room you are sitting, that is example of 3D figure that are of cuboid shape or cube shape. These all are 3D shapes. Now see, before starting 3D shapes, we want to discuss about their some basics like face, vertex, edges. Let us see, first figure is cube. First figure is cube. What is cube? This cube contain all face square. A cube contain all faces square. And in square we know all sides are equal. In square all sides are equal. Let us see. This is shape of cube. This is called base of this cube. Simply I opened this cube, and this is called net formation of cube. Let us draw another shape of cube. This is cube. Now see, how many face, vertex, edge it will contain? What are the face? This plane surface is face of this one board. And suppose you are sitting in a room and you are able to see your left, right, back and forth, top and bottom. These all are faces. And where these faces are meeting, that are called their edges. That are called edges. And where edges are meeting, that point is called vertex. Where these faces are meeting, that are called edges. And where these edges are meeting, this edge and this one edge are meeting at this point, that is called vertex. Vertex or corner. Vertex or corner. And now these are edges, these are vertex, and one point left, face, vertex, face. What is face? This is face. These are the face of this cube. Now let us count how many faces, vertex, and edges does this cube has. Face, vertex, and edges. How many faces? See, if you will open this cube, you will get 6 faces. 1, 2, 3, 4, 5, 6. These are the 6 faces of cube. And vertex, what are vertex? Where edges are meeting, that point is called vertex. Count number of vertex in your cube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3. Once count, in this figure we are going to count 1, 2, we are counting vertex. Okay, 1, 2, 3, 4, 5, 6, 7, 8. These are, we counted these also. These are not vertex. How many vertex are there? 8 vertex are there. Once check out in which room you are sitting. How many corners are there? You will see there are 8 corners in that room. If it is in the shape of cuboid or cube. How many vertex are there? 8 vertex. 1, 2, 3, 4, 5, 6, 7 and 8. After that, count edges. How many edges are there? Edges are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many edges are there? 12 edges are there. It's mean what we conclude, a cube contain 6 face, 8 vertex and 12 edges. And 12 edges. Now see, what will be its CSA or TSA? Let us see what is CSA or TSA. This word I used. Draw shape of this cube again. Okay, now it's a surface area we have to find out. Surface area and then it's a volume. Volume, how much capacity it can hold. The capacity of holding something. That is its a volume. I want to find out surface area. Surface area of cube. Like in 2D figures, we were finding their perimeters and area. And now we are going to find out their surface area. Surface area is of two type in these figures, in 3D figures. One is their lateral surface area and another is total surface area. Lateral surface area and lateral surface area and TSA. TSA stands for total surface area. Total surface area. What is this lateral surface area? And in round figure where faces are curved face, there word I will use CS, that is curved surface area. Now where these figures having edges, there we are using lateral word, lateral. In lateral surface area, we have to count their 4 faces. Suppose you are sitting in a cube shaped room and now count their 4 faces. You have not to count bottom and top. So how many faces you will get? 4 faces you will get. So their lateral surface area means area of 4 faces. Area of 4 faces leaving top and bottom. So if I want to write lateral surface area of cube, lateral surface area of lateral surface area of cube is 4a square. Let us see how this 4a square came. We know all faces of cube is in square shape. You will see all faces of this cube is in square shape. And one square sheet area, how we can find out if it's, we know its all sides are equal, then a into a, that is a square, area will be a square, and all faces are equal and is of square shape, then area of one face will be a square, then 4 faces area if you have to add, then you will get 4a square. And now if I have to find out its total surface area, total surface area of cube. Total surface area of cube will be, we have to include this time top and bottom, including lateral surface area. In total surface area, we have to include top and bottom, including lateral surface area, means area of 6 faces. So one face area is a square, then six face area will be 6a square. So what will be total surface area of cube? 6a square. Now see, next is, in this way, what conclusion we got? We got that lateral surface area of cube is 4a square and total surface area of cube is 6a square. Total surface area of cube is 6a square. Now see, our cube is completed. Now we want to discuss about cuboid. This is net of cuboid. What is cuboid? In face of cuboid, first try to understand that in cube all faces was of square shape, and in cuboid all faces will be of rectangular in shape. So all faces of this cuboid is in rectangle shape. And similarly, I want to tell face, vertex and edges of this cuboid. These are similar to cube, face, vertex and edges. And edges. Let us see, draw shape of cuboid. This is cuboid. This is cuboid. Count number of face. Suppose you are sitting in cuboidal room shape. Now start counting its faces. 4 walls are there and one is bottom and one top. So you will get 6 faces are there. How many faces are there? 6 faces. And you can see in the net of cuboid how many faces. Whenever you will open one cuboid, let me show one shape of cuboid. Consider this box is in the shape of cuboid, although it is in cuboidal shape only. And how many faces this box is containing? One face, second, third, fourth, fifth and sixth. There are 6 faces of this cuboidal box. Now see, start counting its edges. Edges are that point where faces are meeting. This one face and this one face is meeting at this edge. So count number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Edges are 12. Therefore, and these are 4, 8 and these are 4. 2 there and 2 there. These are 12. Edges are 12. Count vertex. What are vertex? As I told you, where edges are meeting, that point is called vertex. Means corner of your room. This is one edge, second edge and third edge. These are meeting at this point. This point is called vertex. Now count number of vertex. Let us count in this figure. 1, 2, 3, 4, 5, 6, 7, 8. So vertex are 8. 6 face, vertex are 8 and edges are 12. Okay, and face of this cuboid will be rectangular in shape. Rectangular in shape. Opposite faces will be equal. Now let us see. This was a basic about cuboid. Now I want to find out its TSA and lateral surface area. In lateral surface area, as I told you, we are going to find out area of 4 faces. Suppose you are sitting in a cuboidal room and you have to find out its lateral surface area. Means area of 4 wall. Means you are not including your top and bottom. So let us draw shape of cuboid. Its lateral surface area. Lateral surface area. Lateral surface area means, let us see, if this is L and this is B and this is H. Breadth of this cuboid is B and length of this cuboid is L, and what is height of this cuboid is H. Now we need to find out lateral surface area, means area of 4 faces, and that 4 faces are is equals to area of 4 faces. If L, B and H I included, let us see how it will be. You have not to include top and bottom. It will be 2 into L plus B into H. Let us see. 2 into LH plus 2BH. You will see L into H. Suppose if this one face area you want to find out, then this face is in the shape of rectangle. You know all faces of cuboid is in rectangular shape. So what will be area of this one face? This is length and this is breadth. L into B. It will be L into B means their B is H. So it will be L into H. Now 2 times why I have written opposite faces are equal. Let us understood with the help of this one box. What will be the area of this one face? Same area will be of this one face. And what area this one face will contain? It will be the opposite of this one also. So opposite faces area will be equal. If one face of forward I have calculated, that is L into H, then back one of this one, which one face will be? That will be L into H only. So 2 times L into H. Now same, suppose if this one face area I am calculating this one area. This one face. And this face is also in rectangular shape. So its area will be B into H. And opposite of this one, next face will be area same. So 2 times B into H. Now after simplification, you will get 2 into L plus B into H. 2 into L plus B into H. This is lateral surface area of cuboid. Now I want to find out the total surface area of cuboid. Total surface area of cuboid. Let us see what it will be. It include lateral surface area plus area of top and bottom. Area of top plus area of bottom of cuboid plus its lateral surface area. Lateral surface area. What will be area of top? See, L into H. That will be rectangular in shape. Length is L and breadth is B. So what will be area of top? L into B. And this top is opposite of bottom. So same area, this bottom will contain L into B. And what is lateral surface area? Lateral surface area is 2 into LH plus 2 into BH. So it is 2 times LB plus 2 times LH plus 2 times BH. What we can take common from these 3 terms? 2 is common, LB plus LH plus BH. So in this way we got area of TSA, total surface area of cuboid is 2 into LB plus BH plus HL. This is total surface area of cuboid. So in this video, we come to know about 3D shapes, how their surface area and total surface area we can calculate, and about their face, vertex and these, and some 2D figures also we studied. In next video, we are going to discuss about cylinder, and then next exercise we will start. Thank you.